Okay, this is 2-1, day 3. Okay, today's Thursday. Remember, tomorrow's notes are already posted online. That'd be 2-2, day 1 for you guys to like get after. If you're not going to be here for whatever reason, if you're in band or whatever that's leaving early, I don't know. I have no idea what the schedule is for tomorrow, but we'll see how it all works out. Today's Wednesday? How's that? Oh boy, the aliens did it in one night. It was awesome. Abduction, so I thought it was like a couple days. Okay, no. All right, so thanks for reminding me. Man, my internal clock is just messed up. Last night I was worrying about it being Wednesday yesterday. So yeah, it makes sense that I feel today's Thursday-ish. So I apologize for that 24-hour experience, and I will start again. Hey, on Friday, though, it is already posted, so if you're willing to work ahead, day 2, I got 2-3 day 2 already posted, and I think 2-3 day 1 is as well. But let's check this out. We did this day 1 on Friday, so it was Friday, and thanks for writing my quote, Ms. Smith. I appreciate it. You already have this data in your calculator, right? Okay, because I want to show you what we're going to do with this data in this next problem. Okay, and it's all about this equation that we found through our regressions. So now, with that said, I'm on that next page for today. Today's day 3, and we're applications of quadratic functions. In economics, when demand is linear, revenue is quadratic, because remember, our demand is about boxes. Okay, the number of boxes we sell at a certain price. Okay, X being that price. But you got to keep in mind, we have this going on, and we're looking at R of X is our revenue, and X is our price per box, and Y is the number of boxes sold here. So if I'm looking at this, I've got my model, and this is our model from our calculator. Let me pop that in because I've got my model in my calculator. I've got my list 3 and list 4. I put that data. Okay, that same data, that revenue data. And when I put in my Y equals, I have my data revenue here, or excuse me, my boxes here, that linear regression we did on Friday. Okay, so that's the linear regression. And now I took my Y2 that's sitting here, and in Y3 I went, hey, I'm going to multiply that Y2 by X. Okay. And that Y2 is going to return a certain data to me, and we're going to talk about why that is before I start flashing that in my calculator. So what we're doing is we're looking at this, we're using our model, our linear regression model, from example 3 to develop a model for the weekly revenue generated by donut-shaped oat breakfast cereal sales. Determine the maximum revenue and how to achieve it. Okay, so the revenue is found by multiplying price per box and number of boxes sold. Okay, right now the numbers of boxes of sold is my Y. Okay, that's my Y. The price per box is going to be X. Okay, as we go through this. So really what I'm thinking about, my revenue function R of X is going to be X times Y. And I'm going to put this in calculator. I'm going to find my max in my calculator. I'm not doing it by hand. That's why I was like, hey, remember this? This stuff's in your calculator. We can even put this formula in, or I should say this linear regression model into your calculator. But I'm going to multiply it by X, because X is the price per box and Y is the number of boxes. So I already have Y. This is my Y value that's been provided. This is my Y. And now I'm just going to multiply it by X. And that's what I did in my calculator. If I slide this out so you can see my calculator, I'm multiplying in my Y3 my linear function that I found, my linear regression function. Notice that the one in the example was rounded to a certain value. I just let it fly in the function itself. And now I multiply it by X, so X times Y sub 2 is going to be multiplying it by X, and I hit my graph. And I get that. Okay. Now what I'm going to do, I'm going to maximize my profit. I'm going to see where the maximum is. Okay. And while I'm doing that, I'm going to check that out, because when I check that part, the maximum is going to be 88,226.727 when X is $2.397. And that's the information I'm going to get from my max. But I guess as I talk about that, maybe I am going to back the truck up a little bit. Is everybody okay with finding the max from your calculator when you're given a graph? Has anybody want to see the review on that? I'm just going to do it just to make sure. For those folks at home, just in case they're not sure of what's happening, I'm going to see if I can bring that calculator up and still leave that stuff there so you guys can get that last part there. So if I get that maximum, if I go to calc, my second calc, and I go to max number 4, I can actually go on the left side of my max. And remember, I can go really close. Okay, maybe not really close. It's kind of not. Okay, I can go pretty close to it, but I want to make sure I'm on the left side, because if I'm not on the left side of my max right away, and I do 2 clicks on one side, whether 2 clicks on the left or 2 clicks on the right, the calculator will return an error message to me. Okay, so in this case, I know I'm on the left of my max. Okay, and now I got to get to the right of my max. Okay, now as long as I'm on the right, it doesn't matter where I am, so long I'm not on the right of the next max, okay, or the next min. Okay, I hit enter, and I can hit it, and it'll actually find my value, my 2.397, because remember, X is 2.397. My Y was 88,226.735. So I was able to find my X and Y value, X being the cost of my boxes, you know, of my brand of cereal we're selling, and my Y being my revenue, okay, my profit. I should say revenue, I shouldn't say profit about that. Okay, so selling each box for $2.40 will maximize weekly revenue. Remember, the difference between revenue and profit is I have to take away all the costs for being in business, okay, because I have to subtract that from revenue and able to say I have a profit, okay, so that's why I misspoke. But that's the graph that you guys just saw, okay, kind of, you know, in a nutshell about what's going on. Are you okay with what I did with this? Okay, and how I defined my Y being the number of boxes sold, my X working with my cost per box. So I was able to find my revenue function. What was my window? Yeah, I guess that, you know, that's really what we're looking at. My window is pretty big when I'm looking at this. Let's talk about my window on my boxes. Okay, first of all, let's talk about our data to help me define my window. So when I'm looking at my data, if I go back, oh, I suppose if we look at my stats, we can actually talk about my data that made my window. Maybe, if I get there. Okay, so my window data is here. And I've got to have at least, I got 38,320, right? So my Y value has to be more than 40,000. Are you okay where I'm getting my Y? Okay, it has to be more than 40. I think I let my Y be 100,000 just for fun, just to see what's going on in my window so I can see it. My X part of my window, 0 to 5, 0 to 10, that type of decision. I have a lot of people that hung up on the windows. Oh, if it's not exact, it's blooms, you know, it's going to be a problem. No, you know, I just got to be able to open it and see what's out there. Okay, if I don't see what's out in my window, if I don't see my graph, I got to expand my window or shrink my window, because, you know, one of the two things is going on. It's either the graph is so small, my window's so big, it's just compressed into the axis, or it's much higher than the window is and I haven't looked up high enough. So I got to adjust my window. But I'm just doing that on data. You okay with how's it's going, Freeze? Okay. But after that, we should be pretty golden with our final on that. Hey, I didn't call her Sub-Zero. Don't giggling over there. Okay, are you all right with that? Any follow-up questions? Okay, so now let's look at this next one. We're talking about the vertical free fall motion. We do it a little differently in math. I mean, they're kind of connected, you know, some of the stuff, but we have a pretty straight up formula for it. The height S and vertical velocity V of an object in free fall are given by the equation S of t, which equals the opposite of 1/2, g of t squared, remember g being gravity, and my gravity can be 32 feet per second, my gravity could be 9.8 meters per second. The difference is whether I'm measuring my results in feet or meters, okay, which one I would use. And then my V sub naught, which is my initial velocity, and my S sub naught is my initial height, okay, as I read this. Now I also got my velocity, and maybe I should just take this out of the way. I'm not sure. But yeah, let's do that for y'all so you can see what I'm talking about there. Now, I have no idea what it's going. Oh, that's what it is. Well, we're going to take this out, maybe. Okay, so I have V of t, which is this is my velocity of the object at a certain time. Okay, so my velocity through the path of the flight of the object at time t as it goes through. Okay, now in this particular problem, I'm going to use my velocity of how fast it's going to be going when it hits the CBR. Okay, and a CBR is this a distance radar. I can hook it up to my calculator. Some people get hung up on what a CBR is, that calculator-based rangefinder. I could put it on my body and then see how, and it will tell me how close I am to a wall as I walk towards it over time. Okay, so, and it will be data that's collected. I could drop something over the top of it, and I think you guys have probably used them in physics. If you've seen it, anybody seen those? They're about this big. Okay, so they're motion sensors, and they'll collect a lot of data as we want to, do something with it. Okay, so and remember this formulas I've got up here. Just completely and totally disregard air resistance. Okay, so when I'm talking about frictions and stuff, I'm not talking about that at all. I'm just going to assume life's perfect in a vacuum. Okay, just hold your breath and just walk in. All right, see what happens. The data in the table 2.3, and now this is new data that we're going to put in. I put it in my calculator, and I put it in second time. It's not in my calculator. I don't have it in L3 and L4. I actually just erased everything and put it in L1 and L2. I suppose you guys would be in L3 and L4 because you guys have that other data in L1 and L2. So let's leave it that way. Okay, so this data, we're going to put it in. Okay, we're going to use the data to write models of the height and vertical velocity of the rubber ball. And I'm just going to release this rubber ball above the CBR, and it's going to collect some data, and that's the data that's collected. Okay. Then use the models to predict the maximum height of the ball and its velocity, vertical velocity, when it hits the face of the CBR. Okay, I'm going to be that good. I'm going to be able to actually put the ball on the CBR. It's actually good that somebody else collected this data, because if I was doing the collection, we'd be missing that quite a bit. Okay, so enter your stuff in L3 or L4, or at least two lists that you know. The L3 list that I have up here, time will be your X value, by the way, when we go through this. So we got time of 0.00, 0.108, 0.215, and so on, and enter in the height of the ball at the time. Okay, and we're going to talk about things as we go. Now we're going to use a quadratic regression, and you guys already see that I have a quadratic regression model up there. I'm going to show you where to get it. I just thought I'd write it down because I didn't want that to be the issue, that I can't write it down, or if I pushed the wrong button, I wasn't going to come up with the right one. Okay. So when we do this model, the quadratic regression, what is that? Number 5 in your calculator. So after you get that stuff in, I'm going to wait for people to get that information plopped in their calculator. We're going to go to that regression area where we found the linear stuff, and we're going to use the quadratic one. Okay. So keep in mind we're going to use that quadratic regression model. And how do I get there? Okay, now remember, all this data that I'm using, I just entered, just going to double check. I've got it in L1 and L2. So I'm going to go second, stat plot. I'm going to make sure it's in L1 and L2 because that's where I put it. If you put it in L3, L4, that's where you put it. Okay, so I put in my X list. My time has got to be L1. My height's got to be L2. And I've got it on, and I got my plot on. Let's talk about my window. Okay, so my window, when I go through that, for my time, boy, it's a really small window. It's less than a second, but I'm just going to open it up from -1 so I could see that axis to 5. And then for my height, I'm going to open it up from -1. It looks like I'm going to open it up to 5 as well so I can see my graph, or at least 4. So I'm going to go to window and adjust my window. I've got -1. I got at least 5, 6, but I'll put it in 5 because that's what I said. And then that's left to right. My up and down. Now, right now, if I go ahead and graph this, it's going to be a pancaked color on my axis because I have such a large window. I'm going to barely see my graph. So I'm going to adjust my window so my graph's better. So I'm going to go from -1 to 4. Okay. And now I'm going to hit graph, and I've got my data. Okay. Are you okay with the data I have right there? Okay. That other thing that came in is proof that I forgot to turn off my other graph. So I'm going to go and turn that off right now. Okay. So I've still got my Y3 turned on. The other graph is my plot 1. So I'm going to take off and deselect that graph so I don't have that coming into my graph at all. But when I go in here, I have Y1 I'm going to do a regression model with. So I'm going to go back into stat and I'm going to go calc and I'm going to the quad regression. I want a quadratic regression. Are you okay with being able to select that? Other than the different regression models you can pick, it's in the same place. I'm doing the same stuff I did with linear. I get to choose. Now what's interesting, if I chose linear, after I do the regression model, I'm going to show you what it is. I want to choose linear and allow you to see what goes on with the correlation coefficient, because if I chose the wrong model, my correlation coefficient's all whacked out. It's like really close to 0. Okay. If I chose a model that works for it, it tries to approximate, it comes close to being 1 or -1, depending on whether it's negatively correlated, if it's -1, or positively correlated. So when we look at this quad 5, I'm just going to hit 5. Okay, I'm in L3 and L4, and I'm going to store it in Y1. So I'm putting mine in Y1. I got my vars. I've got it going. I'm going to hit it in Y1. I'm going to go calculate, and it's going to store it right away in Y1. So I'm going to get my quadratic regression model stored in Y1. I already have my plots in there. My plot has just been, my scatter plot went on my graph. Now I'm going to hit graph. Not only should I see my scatter plot, but I should just now see my regression model coming through, if only it would work the way it's supposed to. Whoops. Let's just double check where I got my data, because I think I screwed up. Yeah, I screwed up. My data's in 0, 1, right? Yeah, knucklehead. It's supposed to be an L1 and L2. That's the problem when I put two data sets in there. So I got to go back. I got to go back in here. I'm going to turn this one off. And I'm going to turn this one on. No, I want that one on. Sorry, I just got to check out my data and see what it's over there. That's 0, that's L1, L2, it's supposed to be an L1, L2, and I think I had the other ones on. So I apologize for that, you guys. So now let's go to my data set, my second calc. Nope. Calc. There we go. And I want my quadratic, I want 5, and I want L1, second L1, and I want L2. Second L2, enter. And then I'm going to go and put it in vars Y1. And we are now golden, and the wheels on the bus are back on. Okay, do you see my coefficients here? My R, 0.9999. Pretty close to 1, right? Remember, that took R and squared it, and it's a quadratic. As long as it's close to 1, it's a really pretty good fit. Okay, so now if I graph, and it should come up now, and you'll see the other stuff, and I turned off that other plot, and I'm going to turn that back on because that should be on, just so you can see that my Y1, Y2 is all good. And now graph. And now we're there. Okay, so it's a good fit as we go through. Now, as I do this, I want to find, this is my release spot right here. My release spot is right there. Are you okay? Right on the y-axis at time 0, the place where my graph crosses the y-axis is my release height. Okay, now I have a maximum height here, and I have, what's that as far as my graph's concerned, that little dot I just finished drawing? Anybody got what that really means? What's that position? Ideas? What? When the ball stops. So where's the ball when it stops? It's on the ground. And really for the purpose of this, because I'm a perfect shot, it's on the face of the CBR, right? That's where it impacts the CBR face. Okay? And the time from 0 to whenever that happens is one of the things I have to seek out. Okay? So I have to find my 0. So and able to find my 0, I've got to go back to second trace. I do the same thing. I'm going to go to 2 for 0. Okay, so I'm going to trace along. I know what this one is. I want to know what that time is. I want to know what that is right there. Okay, so I'm going to go hit my trace and move along. Well, that's too far out. I apologize. I got to move back because this sucker's just above 1 second. I just got to get my trigger back in here. Okay, good. Okay, so we're going to find out what that point is. So I got my left bound. I'm going to go to my right bound. As long as I'm below, I'll be able to find it. And it should be like 1.022. So in 1.022 seconds, it's on the ground. Okay, so what I'm looking at here is I've taken my regression model and I found that it's going to flight time here at 1.022 seconds, it's on the ground. Okay, so at 1.022, it's 0. Now, some of the things I need to set up for myself. If I look at this equation, do you see if I was going to find G, I need to use the fact that my leading coefficient and the idea of this right here, I've been circling with my finger and it didn't work. I'm not sure why. Okay, -1/2 G is equal to my leading coefficient in my quadratic regression. Okay, so that's how and then I've got to pay attention to my V0. Well, V0 is this going to be talking about my initial velocity when tossed, and S0, when I'm looking at that, is the initial height. So when I'm looking at my quadratic regression, I actually put those in. I got my initial height, 1.045. You okay with how I'm reading it from the equation? I got my initial velocity going on at 3.758, and I also have my 1/2 of G. Okay, well I can find G and I can go, what's 9.35, you know, so as soon as I got the 9, I kind of knew I was working with meters, okay, because I had the two choices, because 32 feet, you know, per second, or 9.8 meters per second, okay, remember this is a model, it's not going to be perfect in all things, okay. So I got my G, and if I'm looking at my velocity as I go through, my V0 was 3.758, okay? So my velocity as I'm going through my V0, that should go right in here, and my G that we just found comes in from here to find my velocity equation, okay? So I was able to break down to talk about gravity that was used and my velocity based on my quadratic regression formula. Are you okay with where I got all my numbers? Are there any questions about them? Okay. Now, after I get those numbers, okay, I'm able to go from my quadratic regression and I'm able to talk about my velocity, about when it's going to hit my CBR. Okay. We know how long it's going to be in the air right now. We know it's going to be in the air for 1.022 seconds. So now I take my velocity equation. It was in the air for 1.022 seconds. Okay, so I take my velocity and I plug it in to find how fast the sucker is going when it hits the CBR. Okay, so I evaluate, and I know it's going downward at 5.8 meters per second. That's what the negative means. It's going downward at it's negative 5.8 meters per second, okay, as it hits the CBR. Now, remember, all of this is stuff I'm getting from my calculator. It's me being able to interpret the information and use that data with other equations to make it happen. Okay? Now, part of this problem is not just shoving stuff in and coming up with some answer. It's interpreting, taking my answer and interpreting what's going on. Okay? Do you remember that I talked about my initial release height and the initial release velocity when I pulled that information out? Well, I'm going to talk about that in my interpretation. Okay? I get kind of wordy about it, and I apologize for that, but I wanted to make sure you knew, not knew, but you now know, where everything came from. Okay? And that way you can say, well, I knew that yesterday. Well, okay, tomorrow. So as we're going through this, my interpretation as I go, I'm gonna, at 1.045 meters is my initial release height, okay? About my hip height, okay? I'm throwing a ball up, okay? And the release of the height of the ball, when it was thrown upwards at 3.058 meters per second. And I got that all from my quadratic regression information after I put my data in, because of I felt it would be a quadratic model, okay, versus a linear model. And we can tell it was a good quadratic model because my r squared term was close to 1. Okay, it reaches a maximum, it'll reach its maximum height, and the ball was 1.8 meters above the CBR at its maximum height, and we can talk about maximum height by finding, you know, on either side, just like we did before, and that's something I cheated ourselves out of, is finding the CBR maximum height. But then the ball's downward rate is about 5.80 meters per second when it hits the CBR. So I'm just talking about the information I was able to pull out of that equation, okay? It is not a fast problem, I promise. Some people say, well, you know, it's all about setup. It's all about fat fingeritis too, because when you get your numbers out, check to see if the model you chose is a good fit, okay, by that diagnostics information that we have turned on in your calculator. If your calculator did not return that diagnostic information, make sure that you turn diagnostics on. You can go in your calculator catalog, find the D section, look up diagnostics on, hit enter again, and it'll return it, and it'll have this information for you. Because what I want to show you is what happens in your calculator if it doesn't work. Say I went through all this, and you know, I mean, it's not like it's a secret. I can make mistakes just like the next person. I happen to actually show you guys my mistakes as much as possible. But this is a good one to like learn from. Okay. All right, so I got my data in L1 and L2. What if when I pulled up my calculation, I decided to pull in a linear regression because of habit or a fat fingeritis? Okay, all right, so I'm pulling in everything comes up, no problem, and I go ahead and I try to make it work. You know, I'm going to store it, what the heck, we'll put it in there and see what's going on. I'm going to actually put it in y-vars. I'm going to put it in a different y-vars area function. Actually, we put it in y1. I'm going to use it in y1 just so you guys see what's going on. Maybe. Okay. Now, I'm going to calculate. Totally returns information, but check out my r squared and r. Are they close to 1? That should be a little blinking light to me before I go on to the next stuff. Dude, they're close to 0. This model that you picked was not very good. And that's what this data is referring to. On top of the fact it's supposed to be a quadratic data, I shouldn't have an R, just an R data. I shouldn't just have the R by itself. The quadratic data will return the R squared and not the R. Okay, so we should know that. But say I kept going because, you know, oh, I did it right. My fat fingers aren't that much of an issue. Let's look at graph. Methinks I've made a mistake, right, with my data, because that's not really great as far as fitting my model. So those are the things that should be hints to you that we've picked the wrong model or we've made a mistake in picking a model. Okay. Also, if you plug in a funky number that didn't have a decimal, like put in 36 instead of 3.6, okay, the correlation coefficient will be a problem as well, okay, as you plug that in. Now, with all that stuff said and done, we are done. Okay, today's assignment is day 3, and I think that's the one I've got going on there. And we have day 2. I'm just going to make sure you guys get that up too, just in case for some reason you didn't have that up. So we've gone through day 1, day 2, and day 3 of 2-1. Tomorrow, Thursday, and then Friday, we'll have 2-3, day 1 and 2. We'll go over 2-3, day 3. On Monday, we'll have 2 days of review, and we'll have a test on Thursday when we get back. Okay? So there'll be a test Thursday when you get back. So keep that in mind as we're going. That's our schedule, and that's what we're going to try to adhere to. The next test after that is the 22nd of December. Okay? If we have any snow days, log on in about the middle afternoon time. I'll have had time to come in, make the video, and get you guys uploaded so you can do the video and take notes and then move on. Okay? If there is anything like that, I will probably come up the night of the snowstorm and get it done, because I live kind of close, you know. So just keep that in mind, that that's the policy that Elk River High School has adopted, that because we have the 1-to-1, there really isn't a snow day. On those days, you're just at home getting your stuff done. Okay? Are there any questions? Awesome.